Okay, this is homework 8.4, and I want to talk about figuring out if things are symmetrical or not, and so whether or not they will be polar. Now, XE is not on your chart, your electronegativity chart, which you should have open on your computer while you're watching this tutorial. Your electronegativity chart doesn't have anything for that column, but we're going to assume that bonds to those atoms are polar because they actually are. They're not very common. They only exist in the lab, but they're good for mental exercises to figure out what's going on. Okay, so we see we have XeCl2, and its EPG was trigonal bipyramidal, and its molecular geometry was linear. Then we're going to say that yes, the bonds are polar, and then we're going to ask ourselves, is this symmetrical? Is a linear molecule symmetrical? Yes, it is symmetrical, so we find that this molecule is nonpolar. Now, let's do ICl3. ICl3 ends up being trigonal bipyramidal because it has 5 domains, but it has 3 bond pairs. Then we ask ourselves, is the bond between I and Cl polar? Well, it's 0.5 apart on the electronegativity chart, so yes, it's polar. And then we ask ourselves, is this symmetrical? No, it's not symmetrical. This one would tug. These two cancel each other out, but this one would not be canceled by anything, so it is a polar molecule. This one's a polar molecule. Then we take a look at this guy, Seesaw. Does he look symmetrical to you? Not symmetrical. So then this one becomes polar. Then next, PCl5. The bonds in PCl5 are polar. Bonds in PCl5 are polar, but we actually get symmetry here. And so symmetry makes this molecule nonpolar. Symmetry makes this molecule nonpolar. Okay, ICl5 is shaped like this. It has polar bonds, and it is not symmetrical, so it is a polar molecule. XeCl4 is shaped like this. It has polar bonds, but it has symmetry, so it's nonpolar. SeCl6 is shaped like this. Despite its polar bonds, it has symmetry, so it's nonpolar. Let's get the back. SeO3 looks like this. Despite the polar bonds in SeO3, there is symmetry, so it's nonpolar. However, on SeO2, also trigonal, planar in its EPG, but bent in its molecular geometry, that's not symmetrical, so that is polar. And finally, PCl3 will take on this shape, tetrahedral trigonal pyramidal. The bonds are polar, and the shape is not symmetrical, so you get a polar PCl3. SCl2 has this shape, bent, so that is also asymmetrical, so that is also polar. But SiF4, those bonds are very polar. SiF4 bonds are very polar, but they are canceled by symmetry, and the molecule is nonpolar overall. I hope that little explanation can help you a little bit. Please feel free to contact me if you're struggling to understand this, and go ahead and try 8.5 now.